Part 4 of Competency 11. In this video, we will work with the unit circle and trig identities. Here you can see some basic trigonometric functions or identities. If you are unfamiliar with these or you need a refresher, please do so before you move on, because you might see some of these elements, the basic properties, on your actual test. Number 1, circle O has a radius of 1 as shown below. What is the value of the angle theta in radians and degrees? Okay, well, first I'm going to work with my calculator in degrees. Okay, well, let's go ahead and put the in mode of degrees. See, I have it highlighted. If you want it in radians, you bounce over, push enter, and then you arrow back over, and that'll get you back in degrees. So let's begin in degrees, okay? But first, you should already see what that degree measure is, okay? Because of this point, and we have x here and y here, the distance here and here are the same. Well, this is a special right triangle, and this is also not just a special right triangle, it is a 45, 45, 90 special right triangle. Okay, and we've talked about this in prior videos. Because that distance is the same, we have 1 as our hypotenuse. Okay, we've seen those before. So that means that we would have, let me show you what we have. We have 180 minus the 90. Okay, that's 90 remaining, but you have to divide that by 2 for those two bottom degrees or angles. So that's what theta is. Theta is 45. Well, I can go just by knowing the special right triangle and looking at my point, I know automatically it should be D. But let me show you another way to get there. Let's say we're going to use a sine, the laws of sine. Okay, so that would mean I would have sine of 90 over 1 equals sine of the theta degree we don't know over, now, okay, and you should know this setup. Okay, notice that 1 is corresponds across from the angle, 90-degree angle. Okay, now across from the angle that we're looking for, we know because of the point given that is the square root of 2 over 2. Now, you may not know this or realize, but the sine of 90 degrees, and remember, I have my calculator in degree mode. Press enter, that equals 1. Well, what happens? If you do your cross multiplying appropriately, right? Okay, going like this and like this, like we show you in grade school or like you show your students, we have the sine of theta equals the fraction of 2, square root of 2 over 2. Now, how do we get that value of theta in our calculator? Well, hopefully you took a little bit of trig or you remember from high school. We need to use our calculator to get this. The inverse sine to get our angle would be sine to the power of -1. That's in our calculator. I'll show you in a minute. That's inverse. And then that square root of 2 over the 2 is in parentheses. Now let's pop that in our calculator. Remember, we are in degree mode where we need to be. This is just to verify the degrees. Okay. Right, now watch. We're going to push second sine. See, that gets a setup I have. Now your fraction and second radical, put a 2 under it, go down, put a 2, arrow over, close a parentheses. Now push enter. We get 45. That verifies the 45 degrees. Even if you didn't see the right triangle, the isosceles right triangle immediately. These are all things associated with the unit circle. Okay. Now, next, you're like, well, what about the radian measure? Well, you should recognize it. Yes, it is just part of the unit circle and basic trigonometry in their identities. Yes, but let's do this, okay? Let's go back to mode, arrow over, press enter for radian, and sometimes I just do this with certain questions just to test out what I get, okay, in case I'm tired. All right. So, second mode. Okay, now I'm going to go back. I'm going to arrow up, grab what we had before, press enter again. Now, I want you to push the toggle button. Push toggle and look at what you got. First, you got your decimal in case you needed it, but use that toggle button above your enter, and that's going to verify that pi over 4 is what we need. Of course, they're all these things are equivalencies, and they're just things that we study when we take trig. Okay, now let's go to number 2. Now, number 2 gives us a related setup. It says use the image below. What is the area of the inscribed square? Inscribed meaning it's inside the circle. Okay. All right. So we have this square. Well, we should already be able to see what we need. Right. And I'll just draw this out just to clarify. Well, we know this is still going to be 1. And if that, verifying that isosceles, okay, well, if we have the square root of 2 over 2 here, and that's from this distance. Let me get my highlight from here to here. Okay, then that's a matching, uh, this is a matching situation or half or symmetric. We have symmetry. That's what I want to say. Well, we have the square root of 2 over 2 here. Well, if you add those together, you're going to get the square root of 2. Well, a square, it says the area of the square. They're telling us it is a square. We're looking at it logically, it is a square. Okay. And if we flip that triangle around, we'd have 2, 4, 6, 8 of those triangles making up the square. So obviously, that is side times side is going to be, or the side squared is the area of that particular special square. Okay. All right. So let's say second radical, put a 2 under it, and then go over, square that. And of course, we get 2. And the area is 2 units. All right. Let's go to number 3. Number 3, given the image below, what is the angle measure of point A in degrees and what are the values of the coordinate point as functions? Okay, this should also be very familiar, although they're trying to trick you a little. Okay, let's note here which says 0.5. That is an absolute value. They're giving you a distance, not the coordinate. Okay. So if you're talking about the not the absolute value, but actually this point here, see, they're not giving you the value of this point. This is the distance from 0 to the point. So the value of that point for x here, x is going to equal negative 1/2 or negative 0.5. Okay, so that's the difference between the distance and the point itself. We're interested in the point itself. Well, knowing that and seeing that, that's the first thing that should tell you x is going to be equal to negative half. Well, that gets rid of A and that gets rid of C. Okay, well, I have B and D. Now let's be logical here. They both have 30 degrees. So looking at this triangle, it is a special right triangle. It is a 30, 60, 90 right triangle. So yes, the degree measure is 30. So that's thumbs up on that. Now, here's the thing. You should know already what the value here is of our y. All we need is this y value to get the last piece of the puzzle. Well, I already know what it is. But if you don't know what it is, you can simply use your Pythagorean theorem to get what you need. So let's do that. So we're going to say second radical, and we need the hypotenuse. And I'm going to just bear with me. I'm going through the motions. I know I don't need to do this, but 1 squared. Please don't laugh at me. This is a teaching moment. So now we take that and we need to take that, and I'm going to do the whole thing. I'm going to say negative and the fraction 1 over the 2, showing the whole thing, go over, close that, and now I need to square that. Okay, now let's push enter and the toggle. Mm, something is amiss. Let me see if I can. Oh, yeah. Okay. Well, first off, it's not going to show what we need. Let me see if I can get it. We might want to go back to radian and see if it'll get it for us, but it may not. Okay. But I already know what it is, but we can see what it isn't. Okay. We know it's going to be positive. But do you really think, looking what I got here, my result from my Pythagorean theorem, my formula, take a look at that. Do you think that that's a half where B is right here? No, it is not. We need D. And if you are looking at your information for your unit circle and your identities, you know that that is the square root of 3 over 2. Okay? All right. But there's a couple ways to verify that very quickly because we've eliminated what it isn't. Okay? And this is a special right triangle. You should know this. Okay? But you may not. You may be tired when you take your test. Okay, so let's just check it on D. Let's check our option. So let's set up our fraction, second radical, put in a 3, go down, put in 2, push enter. Oh, okay, fine. Let's use our toggle, and there it is. For some reason, it didn't want to give us that uh, in radical form, probably because it cut off. Let's see, enter it. Let's try it. See, it's not enough. It wasn't enough of the value for our calculator to pop that back to that fractional form. But we verified it. Always double check. Don't assume that you're wrong. Okay. All right. Let's go to oh, number 4 here. Let's take a look. Okay. All right. Given the inscribed triangle shown below with the diameter of ML, okay, let me highlight that. And there's a reason why they're stating this. Even though in the image you may think, well, that's Captain Obvious. Just give me a moment. What is the measure of angle K? So we're looking for K here. This is a very basic property that they're just seeing if you know it, okay? Telling us that that is the diameter of the circle was essential. If that is the case, then that automatically means that no matter where this K is, as we move it back and forth along our circle, doesn't matter where the point is. It could be over here. We could move it, okay? Doesn't matter. It will always be 90 degrees. That's just a property of geometry and trigonometry. This is just something that we need to know with our circle, not necessarily the unit circle. So that really isn't something that without values that we could put into the calculator and check. They just need to see if you know that. Okay. All right. Well, let's move on to number 5. Number 5, given the image below where the radius r equals 1, okay, they've shown that, which equation below represents the circle? Okay, well, if you look at A, that demands a radius of, well, that would be the square root of 2 would be the radius. Either way, in no way does that give us the radius of 1. So A is out. Okay. B is linear. That is not a circle. That is out. Now, C and D we have left, and you look at your image. Well, I do need to point out that C cosine plus sine equals 1. That's not valid in this situation. Uh, I'm sure it's valid somewhere, but not it might be equivalent to something, but not a circle. So that's not going to work either. So now we're down to C. Well, I believe C. You know why I believe C? Well, all you have to do is look at the given and let's take a look. Let me write it really quick. This is what we're going to have. Okay. We are going to have, uh, well, use a Pythagorean theorem. Okay. Because they're telling you it's a right angle right here. Okay. So we could use it. And we know that we have r squared times cosine squared theta plus r squared sine squared theta equals 1 squared the hypotenuse. Now, notice how I wrote my squaring for my sine and cosine. That is a proper way to do it. Now, you can write it after the theta, but the way I've done it is proper. Now, let's think about this. Well, r squared is actually 1 squared. Well, what happens? R squared equals 1. So I'm just going to simply, erase those. I'm going to get rid of them. Okay. Now, once I do that, and I know this actually equals 1, what do we have left? Okay. So D is the equivalent to that unit circle. Okay. Now, that's not every circle. And if I start putting a value in for R that is not 1, then it's not valid anymore. Okay. All right. Now let's look at number 6. Okay. Which of the following is equivalent to the area of the rectangle below? Okay. This is kind of a tricky conundrum, and it has to do with double angles. And I know that because I'm seeing this 2 times the theta. Okay. Okay. Well, I do know. And if you look at your trig identities, if you have those in front of you, you may notice you see something because we have to say uh, side times side, and they're not equivalent right here. Let me erase what I have here. We're going to have the sides multiplied together, right, to get area. So let's take a look at the trig identity and then our equivalents, and let me walk us through that. So we know that the sine of 2 theta actually equals, sine 2 theta equals 2 times sine theta cosine theta. That is a trig identity. Now, if we're talking about the area of this rectangle, so let me write that. We have the area of this rectangle. So be it whatever it is, okay? We know we have r squared, and then we have sine of theta times the cosine of theta, okay? Now, how could I make this each side equal and make it, make it look like my identity? Okay. Well, let me see here. Well, what if I say, well, I have R and then I see 2 times theta. So let's do that. Okay. So on one side, I'm going to do the right side first. Okay. So I'm going to scoot over just a little. Okay. This is what I'm going to say. I'm going to say we have R squared. I'm going to bring in that 2, leaving, of course, my sine theta and my cosine theta. Okay. Well, that's not what I had originally. I added 2 in there. Okay. So now let's go over and make this equivalent, but to my trig identity itself. Well, and I mean this side of my trig identity. Okay. Now let's go to the left side. Well, I know that some of this is equal to that. So let me write that down. So I know I need R added to it. So I'm going to multiply R to my sine to theta. Okay, so now I have R on both sides, and I have the equivalency of the double angle on both sides. I have my right and my left side. Now look, now you see that's an equivalency. However, that's not what I started it with. What can I do to go back to this here? What I need, the actual area. Well, divide both sides by 2. So let's do that. So I'm going to divide by 2 here, divide by 2 here. Interesting. Okay, then this goes away. That looks like what I started with. So now I have what I have above, what I've put a box around, and I have that equivalency. And then over here on my left side, I have this equivalency. Now let's look at the ABCD options and see if I have that in my options. And I'm looking at A, and I like that. I think I have it. Yes, I would agree with that. I would say A. Yeah, B. That's not what we're doing here is not even related to the cosine. Uh, Double angle and C, we'd have to divide by 2. And if you saw before we divided by 2, it would be too large. It wouldn't match exactly. So that wouldn't work. Now, this is the last question in this video, but before I end the video, I do need to say it is not very likely that you would see a question of this trig identity rigor, okay, on a middle school exam. But you might see something a little more simplistic related to it. So just be prepared for those few identities, familiarize yourself with them, and do a few problems and make sure that if there's any issues, rather situations where you can use your calculator, do so to verify. Okay. All right. This is the last question. Like I said, thank you very much for sharing and liking and the wonderful comments and successes that so many of you have. Kudos to you. Congratulations. Happy testing, guys.